Hello, everyone. Good day to all of you. My name is Naren Selvaratnam, and I'm here to have a discussion about the adaptation and validation of psychometric scales. Now, today in this lecture, I'll be introducing fact analysis and item response theory and how those two can be actually applied when we want to culturally adapt and validate psychometric scales. So this is done in collaboration with our journal, Econ Journal of Contemporary Research, to demonstrate the basic elements of this kind of cultural adaptations. Now, with that being said, I represent Deep Haven Counseling, which is a therapy center and based in Colombo. So both these organizations would be taking part in facilitating this particular process and also the lecture that you are about to hear. Now, let's first go through the learning outcomes of this particular lecture that I'll be doing today. So first, I'll take you through commonly used procedures of cultural adaptation and validation of a scale, like what exactly would be the step-by-step approach for it. And then I'll get you to understand how fact analysis is done. What are the basic things that you need to consider in fact analysis? What are the assumptions you need to consider in doing a fact analysis and all of that? And then what item response theory is all about? What is item response theory and why one should consider item response theory? And in addition to that, how fact analysis and item response theory can be applied on both dichotomous and polytomous data. So I will be using a research study that we have done to demonstrate the overall application process. Now let's start from here. Now let me give you a bit of an introduction as to why I am interested in fact analysis and this kind of validations. I can remember when I took my class in psychology statistics. This was back in 2011. We had a class called PSY 231 in my university, Winona State University. So I was a weak student in mathematics, but with the help of the professor and also the textbook, I was able to learn a great deal about the basic statistics required to do psychological research. And then when I got into research methods, I knew that research is one of those areas that I truly am very passionate about and also I have interest in. So little by little, I started to go through my degrees and then I started to teach research methodology for postgraduate students from 2016 onwards in a private campus in Sri Lanka. And then the university actually had no particular component on scale validation and adaptation in the quantitative research methodology syllabus. So at that time, I decided to just touch upon these things for the students because this is something that I always was interested in. And even when I did my MSc in psychology, I didn't get a chance to learn these exact theories. So most of the things that you would be finding in this particular lecture are everything that I have self-learned from 2014 to 2018 time period. So so during of the years from 2015 to 2021, I have been teaching research methods for postgraduate students who did actually psychology degrees and also did education management. So these are things I have learned all throughout those years. And as I said, these are self-learned. And so when you listen to me, it might look or it might sound like that I explain things in more of kind of like a layman kind of terms. So that is some heads up that I wanted to give before we start this lecture. So yeah, so let's begin. So cultural adaptation and validation. Now, one of the first questions one could ask is why exactly this kind of adaptation and validation is important for us? Like what purpose does it serve? So that is a common question one could ask. Now, this is something very relevant for psychology students those who are doing bachelor's, those who are doing masters, those who are doing PhDs. It's very important for them. So as you may know, we don't measure physical objects in our field. For the most part, we are measuring things that we cannot see. So they are abstract things, intangible in some sense. So because of this, what happens is we need to have another method of understanding the mental state of a person. So for these kind of things, we have come up with certain measurement styles or techniques. So for example, a psychometric scale is something like that. So the degree to which this particular psychometric scale could measure what it claims to measure is something that we are very interested in, because if it fails to measure what it claims, or if it measures something other than what it claims, then of course our research is going to get seriously affected. Now, that is one of those things. And at the same time, both language and culture of a specific population also has a major impact on how that chosen population will interact with this uh, psychometric scales. For example, certain languages, they don't have the words. Now, for example, I can remember now in this lecture, you will see that I'll be talking about the generalized self-efficacy scale. We wanted to translate it to Sinhala, but the issue was, what is the word for self-efficacy? And there is a Sinhala word, but that word is not the exact word, because when you get the Sinhala word and then you translate the Sinhala word to English, then the meaning actually comes as endurance, not necessarily efficacy. So most of the times people confuse efficacy with confidence as well. So confidence is very different from efficacy, because confidence is a trait, efficacy is a mental state. So because of things like this, it is very important that we understand the fundamental reasons as to why we are selecting these scales and what exactly is the process of doing a proper validation. So validation and cultural adaptation is important, because we need to make scales that are culturally sensitive and also linguistically sound. So I can give one other example as well. Back in 2017, one of my MSc students told that he wanted to culturally adapt and validate the PTSD checklist to Tamil language. So he went to Jaffna in Sri Lanka. So you know Jaffna is an area, it's a war-torn area. Right now it is evolving or developing, but there was a war for about 25 years. Now, when he gave this scale and when we ran the statistical tests, we were not able to form the required factor structure, because one of the questions people have answered is that the answer choices don't align with what we were expecting. The reason is there was one question where it says, if you hear a loud noise, would you be running inside your house? Now, if someone has PTSD, yes, they might do. But if someone has no PTSD, then they might remain outside. But in our population, the Jaffna population, when we gave it, almost everybody said they will be running inside the house, but they don't have any PTSD. So what happens is, when you get the aggregated scores for this one item, it stands out as opposed to everything else. So it doesn't make sense. These people don't have PTSD, but they just keep on running inside the house. So why exactly? What's the problem? The problem is the area has experienced a lot of shell bombings, and because of the loud noises like the bangs and thuds and all of that, people have learned to go inside because they want to save their life. They might have PTSD, we don't know, but for the most part, it's not just PTSD. It was something that they have learned over the years, because there was a war for 25 years. Now, in that sense, the scale has an obvious problem, because the scale doesn't account the fact the person was, or the particular individuals are in a war zone, or like a war zone, or an area where they had a war for a long time. So because of that, then the questionnaire has to be slightly amended. So if you amend it like that, then you need to again statistically test this. So those are the kind of things. So the experience people had with the war was something that my student missed at that time, and we understood only when we went through the data. So let's talk about now. Let's say now today I'm not going to discuss 100% about how exactly the entire development of a scale would work, but I would be rather speaking about if you have a scale originally available in English language, how that can be actually taken to another destination language, how exactly you are going to validate, or how exactly you are going to adapt it. So the first thing that you need to do is, if you have such a scale, I usually recommend going for smaller scales before going into bigger scales. If you are a person who is expecting to learn more about how to do this, and you plan on learning this process, the best case scenario is to go for a smaller scale with 10 items or something like that. That's what I did as well. So first thing you got to do is you need to obtain permission from the original authors indicating that you would love to statistically validate and adapt it to a particular language. And then you do the translation. So if it is in English, now from English, we translated it to Sinhala. And once you do that, you again take that Sinhala translation and then you translate that again to English. We call this the back translation, because then once you do the back translation, you can see whether that back translated version and the original English version is similar or different. If there are major differences, which means there's a obvious problem in the forward translation, which means the first translation. And then we take it through expert review. We'll talk about what expert review is. And then we do take it under a pilot study. And then we can do content validity. You can get some amount of validity. Okay. And then you can then do the proofreading, and finally the psychometric testing. So this is the process. So some people actually don't do the expert review, and they kind of substitute content validity alongside the content validity to expert review, because expert review is pretty much talking to a group of experts in the field and getting their insight on how good the translation is and all of that. So you can sometimes get content validity on that same spot and complete validity, bringing content validity and doing the expert review in the same process. So we use a specific method for it. We discuss about that as well. So let's move from here. Let's discuss about the translation first. So the scale should first be translated into the desired language. That's the first step. And then the translated one should be translated back to the original language it was. That's the back translation that I was speaking about. So here, discrepancies in the translation should be corrected through the expert review committee. So what you can do is you can actually have a committee, about 5 people who are experts in the field of psychology. For example, they could be lecturers, they could be practitioners. There needs to be some diversity also. You can't just get all your colleagues in the expert review committee, because then the insight might be slightly limited. So you can have this expert review committee. So when you do the first translation, first you can go and talk to them and say, okay, how good is my translation? Because you need to make sure this is properly translated word to word. You can't have additional words. When you have additional words, then the purpose is lost. So it has to be word to word translation. And then you can talk to expert review committee and ask, how good is this translation? If the first translation has errors, then you can correct it. And once you do that, then you do the back translation. And when you do the back translation, you can further realize, okay, what are the problems that you may have? Now, for example, we had difficulty finding words in our language, Sinhala, for self-efficacy, for coping and things like that. Earlier, I was saying about a Sinhala word. Actually, that was coping. So in coping, the Sinhala word usually what we call is daraganima. But when you back translate it, it comes as endurance. But coping and endurance are two different things. So you might have to figure out other strategies for words like this. And sometimes there won't be any other words that we can use. And sometimes the Sinhala word that you might use may not make a lot of sense for the usual average Sri Lankan. So because of that, it's very important at this stage, we finalize the translation. So what I usually recommend is, and what I did when I did my first MSc was, we did 2 forward translations and 2 backward translations to get a solid understanding about how it went. And this was just for a 10-item scale, generalized self-efficacy scale. So you can imagine when the scale becomes bigger and bigger, how much of effort needs to be included in such a process. And then when you have your tentative scale ready, you can get it to undergo a pilot study. So I did a pilot study. I inquired from like about 15 people. Can they understand? And all of them were psychology students. Can they determine whether the questions were translated okay or not? Can they like read and understand all the questions? Are there any questions that are difficult to understand? So, and also at the same time, we can try to find certain inaccuracies. Sometimes when experts are too much knowledgeable about the area, they might miss little things. So in a pilot study, you can always identify these little things. So that's a very important thing. And then from the feedback you obtain in the pilot study, then the scale can further be revised. Once you do this, then you can go ahead and test this for content validity. Now to test this under content validity, we have a process called the Delphi process. And in this method, we get a group of experts, and then we are planning on reaching some consensus from them so that the scale can be finalized. And then you can do the final proofreading and present it for psychometric testing. Now let's try to understand how this Delphi process works and how exactly we are going to get content validity here. So Delphi process, as I said, obtains consensus from a group of experts. And experts present their opinions numerically, which means it is quantitative friendly. Okay. So what we do is we use a predetermined method and we get experts to include ratings for each item in a scale. Let's say my scale had 10 items and I'm getting a few criteria, and then I would be asking the experts to rate the degree to which each item meet that particular criterion. Okay, so they can rate it from 0 to 3, 4 to 6, and 7 to 9. So 0 to 3 means not so good, 4 to 6 means okay, 7 to 9 means extremely good. So this is how the criteria would work. For a given item, see, if 70% or more ratings of an item were in the category of 0 to 3, 70% of the rating means if you have 10 experts, 7 of them feel their rating should come in the 0 to 3 category for a specific component of a item, assessment component of item. So the item should therefore be reworded to make it more appropriate, which means you can't go for statistical testing because you need to correct this here. And if 70% of or more of the ratings for a particular item were in categories 4 to 6 and 7 to 9, then you can retain the item. Now I can show you one example. So the following was the output of a research I carried out in 2014 for my first master's degree. And as I said, I adapted the generalized self-efficacy scale to Sinhala language. And here you can see what I did. Now, these are my 10 items, okay? And these are the specific criteria that I assessed. This was exactly what another paper suggested, so we pretty much replicated that here. So the first is appropriateness of each item. So I had 5 experts. The 5 experts have to say how appropriate each of these items is for the particular scale that we have. And then they had to rate the degree to which items assess the concept. So this is like overall question. Now, as you see here, all 5 of them have agreed that these items are good. That's why I have written 100% here. So I haven't included the percent here, but it's a percentage value. So 100, which means all 5 of them have agreed the items are okay. So 5 of them have rated 7 to 9. So I aggregated them and put it in the percentage format here. Items are also okay. But here, if you see appropriateness with individuals, I originally developed this for 18 to 30-year-olds. So how appropriate is this for this particular age group? So one has felt it's like medium. This particular item 8 is like medium for them. But everyone else has felt it was okay. But if you go for conceptual meaning, now no one has rated it here, which is good. But if you notice, some have felt that the uh, translation can further be improved. Well, technically speaking, as per the criteria that we discuss, I don't need to reword this. But if you think that you need to get the score to be higher on this right column, like 7 to 9 column, then you can see what are the things that they have suggested. And based on the suggestions, you can further do amendments. And then the cultural relevance, okay, cultural relevance. So when you do this, you ideally have like 5 pieces of paper with their comments on it, and you have to go through each comment and see how your scale is going to be further amended, like what kind of things you are going to incorporate into this process and all of that. So this is technically Delphi process. If you are if the ratings are all okay, then you can go ahead with the statistical testing, psychometric testing. Now, for you to do the statistical testing, psychometric testing, first thing is you need to find the right sample. So usually we go for random samples. In my case, I went for a random sample because it's a self-efficacy. Self-efficacy is a universal construct. Everyone has it, and people can easily respond to something like that. And because of that, anyways, to improve the generalizability of your findings, a random sample is advised. So, but then the question comes, okay, how much informants we need to gather, like how many people we need to gather for this study? So there's a minimum sample size that is required. The minimum sample size is 10. You need to have a minimum of 100 participants to run a basic fact analysis or to do this kind of a study. But the issue is when you have a lot of items, then even 100 could be a very smaller sample. So what we do is there is something called subject to variable ratio, 10:1 or rule of 10. So what we do is basically we get one item, like 10 individuals per item, which means you have 10 items, 100 individuals. Now the question is, the self-efficacy is a unidimensional scale, so which means it's just one variable. But at this point, since this is something that we are about to test, I guess without calling it subject to variable, I think you can call subject to item. So based on item, you would be getting individuals. So 10 individuals per each item. And so once the sampling strategy is finalized, then you can proceed with data collection. Now, many years ago, I found this particular paper. I haven't included it here. It was on some other website, and where they have given a bunch of research that you can refer to understand how this how the sampling strategy needs to be done, because you need to have justification. If you are a doctoral student, definitely you need to justify why you have decided to go for a sample size like this. So this rule of 100, rule of 200, rule of 300, and so on, and then subject to item ratios, you need to find credible research papers to justify your stand. So if anyone of you require it, you can email me. I have given my email address, so and I am more than happy to send the PDF document. So once you figure it out, the next thing that you need to do is psychometric testing. So I adapted the process Dr. Ralph Schwarzer utilized in the original translation and original generation of his self-efficacy scale. So the first thing you need to do is, now let's say you get the sample, let's say 200 people, and then you give the newly translated scale to all these 200 people, and then they give it back to you, and then you enter your data to SPSS. So I'm not going to talk about how data needs to be uploaded to SPSS, but that would be the basic process. And once you do that, okay, the first thing that you need to do is to take it through a correlation matrix. Through a correlation matrix, we try to see whether there are any signs of multicollinearity or singularity. So each item under a specific factor. So, you know, if it's a unit now generalized self-efficacy scale, it has one factor. Factor is self-efficacy. So under that, we have different items. So theoretically, based on other translations and other adaptations, because right now we haven't tested, but this is what we are assuming at this point. It would be just all 10 items would lead to one factor. So if that is the case, then all items in this particular scale should correlate with each other to a certain extent. But however, it should not correlate too much, like 0.9 and above kind of correlation is not good for a scale, because then then those particular items are not so unique, because it seems like they pretty much test the same thing. Because under, if you get the self-efficacy scale, each item assess different aspects of it, and we have included the aspects or the items that can assess a greater degree of efficacy in a person. So if two of the items have a correlation of 0.95, which means they are pretty identical, which means one can be retained and then the other can be taken out. So multicollinearity occurs when items have high correlations, and singularity means perfect correlations. If two items have perfect correlations like 1, then obviously, which means they are identical, so then you can definitely take one out. And that says a lot about the initial translation process and other problems as well. So in my experience, I have never seen a singularity, but multicollinearity, of course, it could occur. And then once you do that, then we can do the Kaiser-Meyer or KMO index. This is done to understand sample adequacy. So here, this is a test. Here, this one tests the adequacy of the sample size to conduct principal component analysis. So there is a form of analysis that we do to understand the number of dimensions, principal component analysis. We'll discuss about that later. But for the time being, after correlation matrix, the next one would be KMO index. And then through that, we go for Bartlett's test of sphericity. So this is to investigate how the current correlation matrix diverges from the identity matrix. So here we check if the observed correlation matrix diverges significantly from the identity matrix. So here, remember, the outcome of this test should be significant in order to reject the null hypothesis, which is what I have given below, and proceed to conduct the principal component analysis. So you want to conduct the principal component analysis, you have to make sure your Bartlett's test of sphericity, it yields a significant value. And Kaiser-Meyer-Okin index, the value should be more than 0.6. That is also something to note. And I have given how to do the interpretation. So the current correlation matrix significantly diverges from the identity matrix, and this is how you would do the interpretation. And then you can go ahead and do the principal component analysis to see how many components or how many factors are there in this particular scale, the newly translated 10-item scale of generalized self-efficacy. So when you run this, how exactly are we going to determine how many factors we have? The first one is identifying in order to identify the factors, the basic method would be Kaiser-Gattman eigenvalue criterion. So anything above eigenvalue 1.0 are significant factors. Okay, so then we can determine how many factors we have now. Ideally, since self-efficacy is just one factor, then you should be getting only one factor with the eigenvalue above 1.0. If there are multiple, which means there are multiple factors, so there needs to you need to do the rotation techniques to figure out why exactly the base number of the factors for your scale, or maybe since generalized self-efficacy scale has been translated into multiple languages, at least 20-30 languages, and where they have found it to be pretty much single factor universally, I would actually go back to my translation and check whether I have done any mistake in my translation. And then you can visually inspect the number of factors in the scree plot. I'll show what the scree plot is. And then reliability. The reliability you can do through Cronbach's alpha. So it averages all the possible split half reliabilities obtained from the data set, and it's something that you can do to measure internal consistency of your scale. And then validity, of course, we have taken content validity and consensual validity through Delphi process. But you can administer, you can do actually criterion validity as well. If you want to do criterion validity, when you administer your scale, you have to administer another scale that might actually relate very well with the concept that you are testing, or the construct that you are testing. Now, for example, when I did this particular study for generalized self-efficacy, the first time we didn't do criterion reliability, criterion validity. But when we did it for a second time, we simultaneously administered teacher's sense of efficacy scale as well. So teacher's sense of efficacy is a scale that assesses a particular domain of self-efficacy. But generally speaking, if someone is efficacious in their teaching, they need to be efficacious in their general normal life as well. So we administered both the scales, and we found a correlation of a Spearman correlation, actually not a Pearson, 0.574. So that is something that we observe. And then you can check based on your principal component analysis whether your scale is unidimensional or multidimensional. So I'll show how exactly we did it. Now this sample scree plot, factor number and the eigenvalue. See, now there's one factor. Now this is a pretty significant factor because it's the eigenvalue is 6 point something, which means it can explain 60% and above of variance. Now this one is a secondary factor, 1 point something, but without seeing factor loadings, we cannot clearly say whether we want to accept this as a factor or not. So at this week, we know that there are, actually this one seems to be significant as well, and this one seems to be significant too. So there are certain factors, but then whether to consider this as separate factors or not, that would require certain other steps. We had to go through factor loadings. So, but before we go there, let's try to understand what factor analysis is all about. So think like this. There's something that I learned in sociology called manifest content and the latent content. Manifest content means the things that you can see outside, like you can directly see them. But latent content is something that you cannot directly see. They are abstract. So we want to know how exactly these kind of abstract things can be understood. So factor analysis is used to uncover this latent structure, the dimensions of a set of variables or set of items. So there are 10 items. So I need to know whether these 10 items can be reduced to a single statistical dimension, because every other adaptation pretty much says that this is unidimensional, which means one dimension. So when I translate this to Sinhala, I need to know whether this is unidimensional or not. So having these kind of understanding is really important, because then you know what kind of items assess the concept and why it is important to be included in the assessment, so that when you work with the client, even when you do your psychotherapy, you are much more sensitive towards the explanations or answers of your clients. Now, this concept of factor analysis originally came a century ago with Charles Spearman's attempt to show that a wide variety of mental tests could explain by a single underlying intelligence factor. So I think it's called the G factor. It's a notion now not being widely accepted. So let's see why exactly we use factor analysis. One is to reduce a large number of variables to a smaller number of factors for modeling purposes, where the large number of variables precludes modeling all the measures individually. And then to establish that multiple test measures the same factor, thereby giving justification for administering fewer tests. And then to validate the scale or index by demonstrating that its constituent items load on the same factor. So if you have one factor in the generalized self-efficacy scale, then all 10 items should come under that, nowhere else. And To select a subset of variables from a larger set based on the original variables have the highest correlations with the principal component factors. So if you are developing a scale for the first time, maybe through this process, some of the unnecessary items can be taken out as well. And to create a set of factors to be treated as uncorrelated variables as one approach to handling multicollinearity in such procedures as multiple regression. So about multicollinearity, we won't be discussing too much since this would be just a demonstration of the basic process, but these are just things that you could just notice. So now since you understand how to do basic validation and fact analysis and the process that comes before fact analysis, now let's see what are the assumptions to run a fact analysis. So linear relationships, interval or near interval data, and untruncated variables, proper specifications, so and then lack of high multicollinearity, and then multivariate normality. So fact analysis generates a table in which the rows are the observed row indicator variables and the columns are the factors or latent variables, which explains as much of the variance in these variables as possible. Okay, so I'll show it in the next slide. And the cells in the table are factor loadings, these ones. This is the factor loadings table. This is the basic principal component analysis output. Okay, and then so PCA or principal component analysis is the most common type of fact analysis that a lot of researchers would do, but there are other types of fact analysis as well, and some people call it's not a fact analysis. Fact analysis is different like than principal component analysis, but we are not going to get to that debate in this one. So let's go through the PCA table. Now this is from the generalized self-efficacy scale. See 10 items, 10 components here, they have given scores. And the first one here says 3.879 and explains 38.795 percent of variance. So these are the eigenvalues that we generated. 3.879, 956, 925, 796, 775, 732, 584, 511, 450, and 398. So since only one component has an eigenvalue more than one, so we'll be only retaining this. So which means this is a unidimensional scale. This has just one factor. And you can see the factors or the items that are loaded under factor 1. See, all the items are loaded here and others they don't have. So I'll do another comparison later so that you could do like a proper comparison between components and see. But since this one is just a good indication of a unidimensional factor, like a good validation, so this is exactly what you would see. So they have extracted the component and all the items load under this one without any issue. So it's unidimensional. So key concepts in fact analysis. So there are two types of fact analysis called exploratory fact analysis and confirmatory fact analysis. Exploratory fact analysis seeks to uncover the underlying structure of a relatively large set of variables. This is very common, and if you are doing fact analysis for the first time for a scale, you can actually go ahead and do exploratory fact analysis. So you are exploring how many factors are there in your scale. But if you are already sure about how many factors are there in the scale, but you need to do it for a second time, then you can maybe go ahead and do confirmatory fact analysis as well. So this is to determine if the number of factors and the loadings of the measured variables on them conform to what is expected on the basis of some pre-established theory. So technically, I could have done CFA as well, confirmatory fact analysis, without going for EFA. But the reason that I didn't do it was because the normal SPSS won't allow you to run a confirmatory fact analysis. So you need to have another extension for it called AMOS. And when you have that, you can run the confirmatory fact analysis. And there are other softwares and extensions as well. So you can use those ones. And then through that, you can go ahead and run a confirmatory factor analysis. But in this one, I don't speak about the confirmatory factor analysis. I will be purely focusing on exploratory factor analysis. So now let's try to understand factors and components. So factors represent the common variance of variables, excluding unique variance, and is thus a correlation focused approach. Okay, so this is a correlation focused approach, but when it comes to components, they reflect both common and unique variance of the variables and may be seen as a variance focused approach. So this is one of the differences. So PCA is generally used when the research purpose is data reduction, to reduce the components in many measured variables into smaller set of components. So 10 items, we have reduced it to one component, significant component. And there's another one called principal PFA. And here it is generally used when the research purpose is to identify latent variables which contribute to the common variance of the set of measured variables, including variable specific unique variance. This needs to be PCA as well, not PFA. Give me a second here. Yeah. So PCA, okay. So PCA is generally used when the research purpose is to identify latent variables which contribute to the common variance. So that is something that I wanted to say here. Okay. Alrighty. Yeah, so principal component analysis, by far the most common form of factor analysis, and PCA seeks a linear combination of variables such that the maximum variance is extracted from variables. And here you can also observe the type of components you extract. And now there are two types of components. If the components that you extract should not correlate with each other, then we call them orthogonal factors. If they need to correlate with each other, then we call them oblique ones. So PCA removes this way. We were talking about PCA, about the variance and how it is extracted from variables. So the PCA then removes this variance and seeks a second linear combination, which explains the maximum proportion of the remaining variance and so on. And you can do this one as well, principal axis factoring, PAF, which also again demonstrates another form of factor analysis. So in my opinion, as far as my understanding is concerned, I don't really recollect the exact difference between PCA and PAF, principal axis factoring and principal component analysis. But I usually go with principal component analysis, since my idea is to generally reduce the number of dimensions to see how many dimensions actually are there in my sketch. So PCA therefore analyzes the total common and unique variance. So you can actually follow this particular link I have given and download the exact data set of Dr. Ralph Schlosser and try to identify how exactly he has the data that they have gathered. So you can go ahead and do this analysis by yourself, follow each of the steps and see what exactly actually happens. So then factor loadings or component loadings in principal component analysis are the correlation coefficients between the variables and factors. Variables and the factors. So analogous to Pearson correlation, the squared factor loading is the percent of variance in that indicator variable explained by the factor. To get the percent variance in all variables accounted for by each factor, add the sum of squared loadings, factor loadings for that factor, and divide by the number of variables. So, but before you do this, so I have done this process here so that you could see the number of variables equal the sum of their variances, as the variance of a standardized variable is always 1. Okay, so now the following calculation was conducted utilizing the research I carried out in 2014 for my master degree, and we presented this in conference later. And now see here, these are the findings. So here we have the items. Okay, these are the items, and these are the factor loadings. And so you square all of these factors. See 0.542, you square it, the answer would be 0.293764. And then likewise, if you do it for all the 10 items, the total squared factor loadings would be 3.8785321, which is pretty much, you know, the same thing that we got in this one, 3.879. That's the eigenvalue. And then you divide it by 1 because that's how many variables we have. And the total variance, therefore, is equivalent to 38.79. So you can actually do this calculation yourself. It's anyways there in the outcome, but I just wanted to show the concept. And yes, and with that, I also need to tell, I assume I have taken this from my research. If you download Dr. Schwarz's data set, and if that gives the same results like this, then this should be from his research, not my research. So I'm not too sure. I have made this slide some time ago. So if that's the case, I would apologize for that. But I think this is from my research. And if that's the case, then this is my research. So eigenvalues, so also called characteristic roots. The eigenvalue for a given factor measures the variance in all variables which is accounted for by that factor. The ratio of eigenvalues is the ratio of explanatory importance of the factors with respect to the variables. And then if a factor has a low eigenvalue, then it is contributing little to the explanation of variances in the variables and may be ignored as redundant with more important factors. So a factor's eigenvalue may be computed as the sum of its squared factor loadings for all the variables. Now, we have a rule called Kaiser criterion K1 rule. What we do here is drop all components with eigenvalues under 1.0. So this is default in SPSS. And then you can see how this is the components are demonstrated in your scree plot. So the Cattle scree test plots the components as the x-axis and the corresponding eigenvalues as the y-axis. So Raymond Cattle introduced this in the year of 1966. So we already discussed about the scree plot. And then if you have, let's say you did the self-efficacy scale validation, but you have more than one factor, then you need to go ahead with rotations to consider which factors to be retained and which ones to be eliminated. So rotation serves to make the output more understandable and is usually necessary to facilitate the interpretation of factors. So the sum of eigenvalues is not affected by the rotation, but rotation will alter the eigenvalues of particular factors and will change the factor loadings. So oblique rotations allow the factors to be correlated, and orthogonal ones, they are the ones who basically we use in case if we know these factors should not correlate with each other. So I have given some of the rotation methods here. Varimax is orthogonal, Quantimax is orthogonal, Equimax, Equimax and direct oblimin. They are ones that you can use when you don't need orthogonal solution, which means oblique ones, and ProMax is once again non-orthogonal, which means oblique. Now, since we understand this entire process, let's see how we can apply this to a research. So I did a research in 2018 where I re-administered the generalized self-efficacy scale along with teacher's sense of self-efficacy scale to a group of individuals to investigate psychometric properties and then run an IRT analysis on the scale, item response theory analysis on this particular scale. So here's a bit of introduction to what I did. So as I was doing the basic fact analysis, I got to know about item response theory. And then I wanted to understand more about it, but I failed because I was self-learning these ones. And then since I could not comprehend the theory, not the theory, I mean, I can comprehend the theory, but I couldn't comprehend the exact statistical notations. Those things had formulas. So I talked to one of my colleagues, he's a statistician, and then he helped me to understand the formulas. So we still could not run this on SPSS. So I browsed through ResearchGate and somehow found that you need to have R software to run this. So now the problem is I have the software, but I don't know how to run it because it has a different way of doing things. And so at that time I was in Winona State University. So I quickly went to the university and talked to there's this department called statistics consulting. So I went there, then I explained them the theory and they said, okay, look, I haven't come across this particular theory in statistics department, but if it is something important, I should be able to run this for you. And then he ran it for me and the professor ran it for me, but then that was the only time that it worked. And then when I started to do it, I couldn't run it myself. And then I had to again spend a few months working on the script to figure out a method to run it. And somehow it worked while I was working. And so that's it. And all the interpretations I then did pretty qualitatively, like I did the item response theory analysis, but then afterwards, everything else was done pretty qualitatively to figure out what exactly it says about the interpretation. So my interpretations are at very experimental level, but I'm presenting it to you so that you can get an understanding like what exactly it gives. And when you figure it out, you can tell us as well what exactly the rest of the interpretations do say, because and in Sri Lanka, no one else is running item response theory. So one of the purposes of doing this video is to encourage other educators so that education related testing, psychological testing can be made more standardized. So if like-minded individuals can get together, definitely we can crack the code. So I hope this would be useful because of that. So let's focus on the present study. The current study is focused on investigating the psychometric properties of the scale for a second time using exploratory fact analysis and item response theory. So this was done to identify the accuracy of the scoring in each test item to enhance structural validity of the scale. And demonstrating this will increase the instrument's ability in distinguishing individuals who strongly identify themselves with the latent construct of self-efficacy from the ones who don't. And further, conducting an IRT analysis in Sri Lanka would be the first of its kind. So demonstrating the method involved in increasing awareness of IRT analysis were identified as objectives of this particular research. Now, I have given some information about the social cognitive theory and efficacy as well, because I have researched about self-efficacy since 2014 up to now. So which means for 8 years, I have been researching only on self-efficacy in drug abuse situations, self-efficacy in general psychotherapy, self-efficacy in university settings for international students for administration purposes, and now I am applying it on leadership realm as well. So it's a very important theory, but at the same time, most of my understanding came from the scale validation of the self-efficacy theory and understanding the statistical process behind it. So therefore, I would be glad if you also could read a bit about the theory before we go ahead. So social cognitive theory basically highlights the acquisition, maintenance, and change of behavior as a result of the interplay between personal, behavioral, and environmental influences. We call this the concept of reciprocal determinism, where it has another concept called human agency, which believes humans can shape their future, they can make their own choices, and the pillar that drives such agentic perspective is self-efficacy, where a person has the capacity to truly believe in themselves, so then they can efficiently deal with situations and overcome goals, achieve goals they want to achieve. So extensive research shows that efficacy beliefs affect the choice and persistence of behavior. And at the same time, efficacy beliefs can really improve the effectiveness of therapeutic therapy as well when someone is obtaining psychotherapy. So this was originally developed by Matthias Jerusalem and Ralph Schosser in Germany. And if you go to that particular link, you can download a data set of 19,120 individuals belonging to 25 different countries. And based on that, the generalized self-efficacy scale has a reliability of 0.86, pretty solid, and it's unidimensional. And the scale is important because it positively correlates with sense of coherence, health behaviors, optimism, and then influences coping in patients who underwent surgeries, helps in regulatory behaviors, like helps people in weight regulation, alcohol consumption, and people who have higher efficacy are less likely to relapse, and is related to even uncontrolled sexual behavior. So taking up physical activity, eating habits, preventing smoking, like smoking cessation. If someone needs to cease their smoking, they need to believe in themselves. So we have done some research on these ones as well using our scale. So when you need to actually do even criterion validity, you can get some of these scales in these constructs. For example, health behaviors, that is something you can give simultaneously with efficacy. Even optimism and satisfaction with life. So those things definitely go very kind of like hand in hand, and things that you could utilize to see how good the scale correlates with another scale to establish criterion validity. So this is the original generalized self-efficacy scale, and the Sinhala translation is available in my website and in one of my papers. So you can download that from ResearchGate. And so the GSE scale was culturally adapted, and initial statistical validation was performed in 2015. For us also, it was unidimensional, and the reliability was pretty solid as well. And our reliability was 0.818. So item response theory. Now, psychometric instruments can be assessed using both classical test theory and also modern test theory. Classical test theory has reliability testing, validity testing. Modern test theory has item response theory. Now, IRT, or item response theory, is concerned with accurate test scoring and development of test items. So D.N. Lawley of Edinburgh University first introduced IRT in 1943 through his one of his papers. So in 1960s, George Rasch in Denmark had developed IRT models to measure reading ability of military tests. Now, these are some of the IRT models. Now, this is the place that I even got confused because it's very difficult to read this statistical stuff. So I sought the help of a statistician to figure out how exactly that would work. So this is one of the earlier models, George Rasch's Rasch model. One of the limitations of this model is there is no discrimination between items. So this is Rasch model. As you would see, every line has the same steepness. The steepness would differ from one line to another if the discrimination between items exists. So Rasch model doesn't measure that. So this is the item characteristic curve of the Rasch model. And also the other thing is it can only accommodate dichotomous data. And then we have the 2-parameter model, so which is 2PL. And then here you can measure the probability, ability, and discrimination, but again for dichotomous data. And then we have Samijima's GRM, which is Fumiko Samijima's graded response model. And this can be used for polytomous data. Now, that is exactly the one that I used in this particular study. So this is our methodology. We got a sample of 144 ages between 18 to 50 native Sinhala speakers. We use two tools. One is Sinhala Generalized Self-Efficacy Scale, and then Teacher's Sense of Self-Efficacy Scale. And we actually translated this into Sinhala. So we actually administered that. The original one was by Shannon Moran and Woolfolk Hoy, but we actually did our Sinhala translation, which one of my students did. And the reliability statistics were pretty good. I think then the procedure that we did was, first we took our scale through the classical test measures, and then we ran it through item response theory. Now, first, we found the multivariate outliers. So we did that check through Mahalanobis distance. That is a way of figuring out multivariate outliers. And then we ran a correlation matrix to figure out any signs of multicollinearity or singularity. And then we ran the Bartlett's test of sphericity to check the suitability of conducting a fact analysis by comparing the current correlation matrix to an identity matrix. And then we ran the K-Mo index for sampling adequacy. Then we did the principal component analysis to identify the number of dimensions of components in the scale. So significance of the components were measured through the Kaiser-Gutman eigenvalue criterion. And we also utilized the process suggested in the paper by Scholz in 2005. So if we consider a particular component, the component has to have 3 factor loadings, and it should explain at least 5% of the total variance. And we also did principal axis factoring, exploratory factor analysis method that operates under the common factor model. So that is also another factor analysis type that we utilized. So reliability and item total correlation. So we, in the first research, we didn't do this, but in the second research, we did this one. So item total correlation, it's another effective thing to see which items are problematic in your scale. So internal consistency reliability was done through Cronbach's alpha. Then we did the item total correlation. So what is this item total correlation? Here, each item score was correlated with the composite score of the rest of the 9 items to assess which items uniqueness, to assess each item's uniqueness and representativeness of the construct. So you select one item, you get the score of that item, and then you measure it, you correlate it with the composite score of the rest of the items for the entire sample that you have obtained. So this would also support the quality of the items in the scale, and it would assist in identifying how much of influence each item possesses in identifying individuals who score higher and identify the most with the latent trait. And to get the criterion validity, we did the Spearman correlation between Sinhala generalized self-efficacy scale and teacher's sense of efficacy scale. So this is just the procedure, and we can go through results very soon. And then, since Sinhala generalized self-efficacy scale has items with multiple response options, graded response model by Fumiko Samejima was used, which takes all the properties of a 2PL model for polytomous data into account. So there, first we ran a constrained version of the graded response model, where discrimination of all items were held constant. So category characteristic curves, item information curves, test information functions were qualitatively observed here. Now, these are the experimental things that I was talking about. And then we ran an unconstrained version of GRM, where the discrimination varies for each item. Then we did a model fit through the likelihood ratio test. And for this, we used the LTEM package in our studio by Dimitris Risopoulos. So latent trait modeling, that's LTEM. So let's go through the results. First, we did the Mahalanobis distance and 2 respondents were removed. So altogether, we had then 142 for the study. And these are the mean self-efficacy scores, male and female, minor differences. But overall, that's a pretty good score out of 40 because the score ranges from 10 to 40 and 30 and above is pretty good. So no signs of multicollinearity or singularity was observed. Reliability was pretty solid, 0.86. And the current study obtained a KMO index of 0.885. That is also very good. And Bartlett's test is also significant. And the scale is unidimensional. Now, that's okay. But let's go into our item total correlation. Now, this is classical test theory, okay? See, the third item and the fourth item, they do have slightly lower scores compared to everything else. Now, these are pretty good. 5 and above, 6 and above, and all of that. And here in this item total statistics, they also give another very important one. What if we remove one of these items? Would it increase our Cronbach's alpha? Now, our originally obtained Cronbach's alpha is 0.860. So if I remove one of these items, if that enhances the reliability by more reliability, if it increases the reliability to go beyond 0.860, then that item has some problem which we have to correct, because technically that shouldn't be the case. Now in here, in this particular example, we don't have that issue because everything is less than 0.86. But in my experience, we have sometimes seen certain scales where you remove 1 or 2 items, suddenly the thing goes up. The Cronbach's alpha goes up, which means either the translation or the data collection. So some methodological problem is there if translation is all good. So, but for the most part, the issue is with the translation where you can always change it and do a second run of testing. And so this is extremely important. Even if you see everything at a face level, like very good, you can still go ahead and do these observations, because you would see the same thing when we go later into our other next analysis as well. Okay, now this one is even interesting. Now this is our results. As you see, we have 2 factors here. 2 factors. One explains 44%, the other explains 10%. So which means there needs to be a second factor. So let's go through our component matrix. Now component 1 and component 2. You can compare these things. Whichever the component has the higher value, we'll put that, we will consider it under that column, under that component. So component 1 here, 0.6, this one is 0.4K, then item 1 should come under component 1. Here the same, here the same, here the same, the same. Okay, only here, item 6 seem to be on the other side. And here, no issues. So can you remember I told, without even having 3 items, we can't technically consider it as a second component other than the minimum 5% of variance. So since this one has 10% variance, but only 1 item. So because of that, we are not going to consider. But, okay, look at this. Item 6. Even this one says item 6 has a bit of an issue because the correlation is slightly lesser. Now think about having 2 or 3 items like this, where when they are correlated with the rest of the items composite score, if the score is low, technically there could exist a particular another factor. Let's see which one is this 6th question or 6th item. I can solve most problems if I invest the necessary effort. So wonder why exactly that has generated that much of a low score, but there could be unexplained cultural differences as well. And I think maybe 1 or 2 cultures have actually generated 2-factor solutions, like anything more than 1 factor. So that's okay. But here we will be just considering it as 1 factor because you don't need to consider just this one. And this is the correlation. Okay, actually that's not Spearman. I was under the impression that it was Spearman, but no, it is Pearson correlation. and Pearson correlation is 0.574, 0.574, and it is pretty significant as well, and a good correlation. So it's a, I wouldn't say extremely powerful correlation, but based on guidelines of Cohen, it's a strong correlation. So then we ran the IRT analysis, GRM. The constrained one had a value for here, this one, I think, let me quickly go through it here. Yeah, this is the constrained version, okay, where the discrimination of all items were held constant. So the discrimination value 3.190, and the category characteristics were observed for all items, and perfect discrimination among items were observed. In the unconstrained one, where the discrimination was not held constant, some of the items, almost all the items generated values more than 1.0 for the discrimination. However, items 3, 6, 7, 8, now 3 and 6, even here we found 3 and 6, but in this one, even 7 and 8, they have found the score to be slightly low. However, 3, 6, 7, and 8 all had 85.52, 83.3, 89.93, and 89.66. So all of them explain the latent variable at that much of a percentage. So that is all right. And now this one is item 2 and 3, unconstrained. If you notice this one, item 2 explains 99.6 of the latent variable. So the discrimination is higher. So item 2 is very effective in determining the efficacy of a person. Look at how steep this one is compared to the steepness of this one. This one is not super steep, which means compared to item 3, item 2 is better at discriminating the latent trait that we are interested in measuring, in this case, self-efficacy. So something like that. Now this is the one I said that my interpretations are at experimental level, and as I said, these are self-learned ones. So if you think there's a different interpretation for this, make sure to give a comment down below so that we could incorporate them in our future research. And these are some of the output that I got. I have included them here as well. And if you go to my ResearchGate, you can further read on, I have uploaded one of these presentations. So further, item information curves suggested the strong ability of items to measure individuals at different ability levels. Furthermore, the test information function clearly peaks at the mean, further enhancing scales accuracy in scoring. So this was something that I read in one of the papers where they say that it should mean like this to demonstrate the scoring accuracy of the scale. And then we ran the test information function as well. So to see how the entire sample has performed. So you can pretty much see the scoring and also the degree to which the sample represent or identifies with the latent trait. So the likelihood ratio test also suggests the unconstrained version is not the best fit. So we went with the constrained version. So overall, it can be concluded that Sinhala generalized self-efficacy scale provides outstanding psychometric properties in both classical test theory and item response theory. Now, this is the script that I used. This is from R, and I have uploaded this on one of my presentations as well, so that anyone could go through and use, because I don't understand how exactly this writing system works. So I got the help from the statistics department in my university, and then I just played around with that to figure out how exactly this would work. So anyone could go ahead and see if like if you know, or you can go ahead and definitely check this out. And if not, you can take the sample data and run it and do it this for yourself. And there are other softwares as well. I think SAS, Stata, and those things also should be able to run this, but those softwares are pretty expensive and we don't have them here. So because of that, we had to rely on R. So the discussion, compared to the study conducted in 2015, the Cronbach's sulfur demonstrated a slight increase, so that's pretty good. And it is evident that all the items are good at discrimination, and the obtained results clearly represent results demonstrated in Scholz et al. In 2002. And furthermore, unidimensionality was demonstrated through principal component analysis and principal axis factoring, confirming the compatibility with results found in over 25 cross-cultural adaptations. And the significant component accounted for 44% of the total variance, demonstrating close similarity to the results of Swasser and Jerusalem in 1995, which was 43%. The significance of criterion validity indicated the ability of single generalized self-efficacy scale to predict the level of efficacy in people in domain-specific situations, and this adds to the belief that general self-efficacy is a better predictor of efficacy than domain-specific efficacy due to its stability over time. And IRT analysis further enhanced the construct validity of the SGSE scale. So this really adds up the value of everything that we have done. And this research would increase awareness about item response theory among psychologists in Sri Lanka, and IRT would be highly useful tool in standardizing the education system of our country as well. This is something I have been saying for a long time, but more on that can be discussed later. So I have included our references here as well. So if you have any questions or concerns about the methodology that we have used, you can contact us. So Egan Journal of Contemporary Research and Deep Haven Council, we have our office in the World Trade Center in Colombo, Sri Lanka. I have given our telephone number, note 117-517-817, and you can contact us through it by any of the emails I have given here. And if you want to contact me directly, I have given my email address here as well. So thank you very much for listening to this presentation. This was done to raise awareness about item response theory and other forms of scale adaptation and validation, and mainly for our students to learn as well. So I hope I was able to give some insight about this. So if you have any comments about this, feel free to comment down below. So thank you very much and have a pleasant day ahead.